Today we're going to talk about rewriting equations and formulas. And so all we're going to be doing is taking our equations, taking our formulas, reworking them, okay, solving them for different variables, and kind of manipulating them in ways that are going to be helpful for science and other math applications as you get up in high school math. Okay, so the first sentence reads, the equations 2x plus 5 equal 11 and 6x plus 3 equal 15 have the general form of ax plus b equals c, right? 2 would be a, 5 would be b, 11 is c. 6 would be a, 3 would be b, 15 would be c. The equation ax plus b equals c is what we call a literal equation because the letters have replaced the coefficients and constants, right? Coefficients are the numbers that come in front of the variables. So instead of a 2, there's an a. Constants are the numbers that are being added or subtracted or multiplied. So instead of 5, it's b. We've replaced those numbers with variables. And when you solve a literal equation, you can use the result to solve any equation that has the same format or the same form. So it says solve ax plus b equals c for x. Okay, so I'm gonna do it, I'm gonna do it like this. So we have ax plus b equals c. Okay, x is what I'm trying to get by itself. So we're going to solve this just like we would a regular equation, except instead of numbers, there's letters. Okay, so what would be the first thing that you would do? Okay, and if you're like, what? Okay, go back to this form. If I was trying to solve this equation, what am I going to do first? I'm going to subtract 5. Okay, so here, that means I'm going to subtract b from both sides, right? When I subtract b, it goes away, and now it's over here. Okay, but because these are variables and not numbers, I don't know what c minus b is. So I'm just going to leave it as c minus b. So now what I have is a times x equals c minus b. But I don't want to know what a times x is. I want to know what just x is. So now I'm going to divide both sides by a. When I divide by a, these are going to cancel. And what am I left with? X equals c minus b over a. This is my equation. So x equals c minus b over a. Okay, I solved it for x. So now I'm going to use that to solve 2x plus 5 equals 11. Okay, so in this equation, we have an a, a b, and a c. A is 2, B is 5, and C is 11. So I'm going to plug those values in to the equation that I found over here. So x equals C minus B over A. So x equals 11 minus 5 is 6. 6 over 2 would mean that x equals 3. Okay, and I know that a lot of y'all are like, that was the most convoluted way I could have subtracted 5 and divided by 2 and got the same thing, and that's true. But again, this has applications in chemistry and physics, and we want to make sure that we're comfortable with, okay, and familiar with manipulating and solving these equations like this. Okay, so the next one says solve the literal equation for x, then use that solution to solve the specific equation. Okay, so I'm trying to solve a minus bx equals c. I'm trying to solve that, I'm trying to get that light to stop doing that weird thing, for x. So I need to get rid of this a. So I'm going to subtract a from both sides. So now these go away, and I'm left with negative b, do it over here, times x equals c minus a. But I'm still trying to figure out what just regular x is. So now I'm going to divide both sides by negative b, because now these are going to cancel. And look what I'm left with. X equals c minus a over negative b, right? So look at it one more time. I subtracted a from both sides to get negative bx equals c minus a, and then I divided both sides by negative b. So now, looking at this equation right here, okay, a is 12, b is 5, and c is negative 3. So I'm going to use those values, and I'm going to plug them into this equation. So x equals c minus a over negative b, so negative 5. So x equals negative 3 minus 12 is negative 15 over negative 5, which is positive 3. Okay, let's look at my next one. If you wanted to try to pause it and try to figure this one out on your own and then come back, that'd be awesome. Okay, but we can also look at it together if that's easier for you. So let's look at this one. So first I want you to look at this version of it, right? The 11x equals 6x plus 20. I have variables on both sides, just like I have x's over here on both sides. So the first thing I need to do is get rid of this x over here on the right. So I'm going to subtract it from both sides, right? Just like here, I would subtract 6x from 11x. So I'm going to do ax minus bx. So a number of x's minus b number of x's. So let's think about that. That's the number of x's times whatever a minus b is. 11 minus 6, that number of x's. A minus b, that number of x's. So x times a minus b equals c. Okay, do you guys see what I just did there? I did ax minus bx. So 11x's minus 6x's. So 11 minus 6, that number, times x. A minus b, whatever that number is, times x. Okay, so I'm getting closer, but I still want x by itself. So I'm going to divide both sides by a minus b. Okay, and I'm doing that because I want x by itself. The quantity a minus b divided by the quantity a minus b cancels out. Okay, and I know you're like, what? Okay, so think about it over here. I'm just going to rework this one. So it would be like saying 11 minus 6, right? Like that. So, oh, you can't even see that. So that's x times 5 equals 20. And then you would say, oh, well, we're going to divide both sides by 5. Okay, but because we're dealing with variables, I don't know that this is 11 and 6. So I'm just going to write it as, well, whatever the first number is minus the second. So I'm dividing the numerator and denominator, okay, by that, or I'm dividing the numerator by that quantity. And whatever I do to the left, I do to the right. So what I'm left with is x equals c over the quantity a minus b. Okay, so what we have to do now, right, is this is a, this is b, this is c. So x equals 20 divided by the quantity a minus b, 11 minus 6. So that's 20 over 5, which is 4. Okay, let's come down and look at these. It says an equation in two variables such as 3x plus 2y equals 8, or a formula in two or more variables such as a equals 1/2 bh can be rewritten so that one variable is a function of the other. So write 3x plus 2y equals 8 so that y is a function of x. So I'm going to go ahead and I want to get y by itself. So I'm going to subtract 3x from both sides. So now these are gone. So now I have 2y equals 8 minus 3x. So now what I want to do is I want to divide both sides by 2 because I want y by itself. So I have y equals 8 minus 3x over 2. And I solved that for y. So on this one, I have 5x plus 4y equals 20. So I'm going to try to solve it for y. So I'm going to be subtracting 5x from both sides. When I do that, those cancel out. So now I have 4y equals 20 minus 5x. So I'm going to divide both sides by 4 because I want this to cancel out. And I'm left with y equals 20 minus 5x over 4. Okay, go to your second page and let's look at this triangle. It says the area of a triangle is given by the formula area equals 1/2 BH, where B is the base and H is the height. Solve the formula for the height H. Okay, so my original formula is A equals 1/2 BH. Okay, so if H is what I want, right now it's being multiplied by half. I'm going to multiply both sides by the reciprocal, right, because I want that to cancel. So now I have 2A equals BH. So I'm getting closer, but I'm trying to solve it for H. So I'm going to divide both sides by B. And when I do that, the B's cancel. And I have 2A over B equals H. So 2 times the area divided by the base gives you the height. So now, if we're given the area and we know the base, we can find the height. So I'm going to use my formula 2 times the area divided by the base equals the height. 2 times 64.4 is 128.8, and I'm going to divide that by 14 to get the height. Okay, so 128, I'll do it right here, 0.8 divided by 14. 14 goes into 128 9 times. 9 times 14 is 126. 2, 8, 14 goes into 28 2 times. So 128.8 divided by 14, I get 9.2 equals H. And then let's look at this one. So it says the perimeter P of a rectangle is given by the formula P equals 2 times the length plus 2 times the width, where L is the length and W is the width. Solve the formula for W. Okay, I'm going to do it down here because I just have a little more space. So P equals 2 times the length plus 2 times the width. And we're trying to solve it for W. So the first thing I need to do is get rid of this 2L from over here on the right. So I could say that the perimeter minus 2 times the length equals 2 times the width. But I don't want to know what 2 times the width is. I want to know what just one width is. So I'm going to divide that by 2. Okay, so P minus 2L over 2 is equal to W. Okay, the width is the perimeter minus 2 times the length and then divided by 2. So now it says use the rewritten formula to find the width of the rectangle. Okay, so the width is equal to the perimeter, which is 19.2, minus the length, which is 7.2. Oh, sorry, minus 2 times that, divided by 2. So the width is equal to 19.2 minus 14.4 over 2. 19.2 minus 14.4 is 4.8. And when I divide that by 2, I get my width as 2.4.